4.3, modeling with quadratic functions. Get your handy dandy calculator out because you're going to need it. Okay, so this is review from chapter 2 also, but just a little twist. If I want to look for parabola, what is a parabola? Remember, that's the word we use for when a graph looks like a U. It usually has to do with an x squared. So I'm looking for the parabola that contains these 3 points. I'm going to use my graphing calculator to do this. I'm going to first, so I can stay nice and organized, write these points in a table. So I have 0, 0, -1, -2, 1, 6. So this is my x, this is my y. This is my L1, this is my L2. Oh, wait, I remember L1 or L2. Yeah, you do. So first go to stat. Then you push enter to edit. You want to clear out your L1, clear out your L2, plug in your number. So 0, enter. -1, enter. 1, enter. 0, enter. -2, enter. 6, enter. You have to make sure that these are points right here. Then I'm going to go back to stat. I'm going to calculate. Before we did linear regression, and that was in the format y equals mx plus b. Now we're going to do quadratic regression. So again, this is going to come up with an equation that if for some reason I wanted to guess another point on the graph, I can do so. It tells me my a value. I can plug that right in. So my equation is going to be y equals, my a is 2. It's telling me right there. And then I have my x squared. So looking at that graph, my b is 4. So the b is multiplied by my x. This should be familiar to you because this is in standard form. Standard form. So right now, I want you to pause the video, use that same graphing calculator that you got going on, and type in these 4 points. 3 points. And you should have gotten -3x squared plus 1x plus 0. So we're going to go on with that and talk about what if we just have data points. So if, again, we use this if we want to try to predict some information. Now, when we're talking about my input, this is where in quadratics, you have to be very careful. When we're talking about input, you have to make sure that you're going to be starting. If it's a year, we would start at 0. If it's going to be time like this, it has to have military time. So after 12 p.m., we can go to 13, 14. So 2 p.m. would be 14. So in military time. And then this would be 15, 16. So this would be 16 in military time. Or else you could do 12 plus 6. That would give you 18. So when I'm typing this into my calculator, again, stat, edit, clear out what you just found out for your last problem. We have 8, we have 10, 12, 14. Make sure that be careful when you're plugging these into your graphing calculator. Oops, sorry, guys. You're over 52, 64. And if I'm going too fast right now, you should pause the video, type in the information on your data set. So now I'm going to go again. Stat. Over to calculator. We want quadratic regression. So that's 5. Keep on pushing enter until you formulate your answer. Now, when I'm writing this, I again want 4 decimal spots. So my 8, you have to be careful to make sure you have a negative 4, 6, 8, and then that 5 will move it up to 8, and that has the x squared because that's my a value. And then plus 14.7161 multiplied by x plus a negative, so you can put subtraction there or plus a negative 36.1214. So this is my quadratic model. Now, this is where I want to predict the high temperature for the day. I can do this in one of 2 ways. I can either do this mathematically or else I can do it on my graphing calculator. And I'm going to actually do it mathematically. So remember how we did this mathematically? If I want a high, that means I'm looking for my maximum. So again, if I were to sketch this graph, it would look like this. This is my A value, B value, C value. So opposite B over 2A. Remember that from 4.2? So opposite B over 2 times A, -0.4688. If I plug that into my graphing calculator, no. Okay, I'm not gonna lie, guys. I don't know where I last talked to you on here. So I'm gonna go over these answers. Sorry about this. I thought you were listening. So opposite B over 2A. So that's this value right here. That's my x. I plugged that back in. So this was my opposite b over 2a. That's that value right here. I plugged that into my equation. So this equation right here. For the x squared and for the x value, I plugged in my answer. And I got my y value to be this. So this is my highest point right here. That's the highest point right there. So I'm talking about maximum right there because this is flipped. So when I'm looking at this, my predicted high temperature, I have to go back to my chart. My chart temperature is my y value. So when I look at my vertex, my y value is the 79. So this is my highest temperature. The next question says, what time? So that's my x value. This is in military time. So if I keep it in military time, I would say 15:30. Or else you can always do 15. So this was my x value, subtract 12 if you want to go back to PM time. So since the 0.6, I said roughly 30. And that's okay if it's not precise, as long as I can somehow see your answer. Right now, I want you to come up with your quadratic function by yourself. So first thing you want to do is change these so that they're not, or so it's all in military time. Again, you could go 12 plus 3. This would be 15. 6 plus 3, 9 plus 3. Type this into your graphing calculator and get your quadratic model right now. So this right here should be your quadratic model. So again, both of these are talking about high temperature. So I want you to try to come up with your vertex. Right now, come up with your vertex with the equation opposite b over 2a. So using this equation, come up with your vertex, and then we will answer the questions. Okay, so your vertex should look something like this. Opposite b times 2 times a, that was my x value. Plug it back in here, where x is squared times x. So that whole equation, we're always referencing back. This is my y value. So it says predict the high temperature. Again, my high temperature was my y value. So my high temperature for the day would have been about 65.0881 degrees. At what time? So this is the time. Now this right here is going to be already, we don't have to change, we don't have military time here. So again, that's almost 6:30 because it's almost a half, or else you could say it's 6 a.m. Something's not right there. Just kidding, guys. Ha 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 ha. This is what you should have gotten with your opposite b over 2a. Plug it back in here. This is what you get. How did I know that was wrong? How was I like, something doesn't seem right? Well, because when I look back at this chart, this should be pretty close to what this represents. And it didn't make sense that my highest temperature was 65 degrees. So going back now here, 14, predict when the highest was. So it's 14.87. So if I subtract 12 from there, this would, I would say probably at 2.45 p.m. Again, it doesn't have to be precise. It's just roughly where it's going to be. So it should be 2 and then over a half. And then that's this one. Golly gee jeepers, Mrs. Frickman. My highest temp was at 88.4258. 88.4258 degrees. And there you go. Wow, making mistakes is great because it actually helps your brain grow. Did you know that? Now you do. Hope you have a great, grand, wonderful day.